Good evening, everyone. If I may have your attention, welcome to V2, the Institute for the Unstable Media, and welcome to Test Lab Clothing Without Cloth. My name is Michel Nachtel, one of the curators here at V2, and it's my pleasure to welcome you to this event tonight with two reasons to get excited. One is that we have an incredibly exciting lineup of projects tonight that will all be demonstrated to us by the people behind these projects. And at the sort of second informal part of this evening, you'll get a chance to have a closer look at all these projects that you'll see demonstrated, and also try some of the stuff out yourself and experience it from nearby. Also, of course, talk to the people behind these projects. Second reason to get excited is because tonight's edition of Test Lab is guest curated by Valérie Lamontagne, right next to me here, who visited the lab at V2 upstairs from here over the last half year. And what she proposed to do was doing part of her research in her PhD research that she was doing at Concordia University here in our lab. And in more detail, she proposed to do an ethnographic study of the research going on in our lab. Now, I don't know what kind of image you have of ethnographic studies, but I always think of this sort of silent onlooker, observing what's going on, taking perhaps a few notes, but being very careful about not disturbing anything of the phenomenon you're researching. I think Valérie took a kind of radical, different approach. She disturbed quite a bit in the V2 lab, and I'm very happy and grateful that she did, because that had many positive things as a result. One of these things being tonight's program, Test Lab Without Cloth. I introduce to you Valérie Lamontagne.
Thank you for that lovely introduction. And we've got a jam-packed evening, so let me begin just by quickly introducing the theme. I'm researching wearable technologies, and as a radical and innovative approach to it, we thought we would look into what the material practices are around that field. And to represent different areas of research, from industry to fashion to art to, a number of truly exciting guests this evening. The first of which will be Emily Crane. She's going to cook up some fashion. The second is Carole Collet, who is doing some quite radical speculative design work. Then we have Christien Meindertsma, who has been working with sheep. Giada, how can I say your last name? Giamacco, hopefully that's close enough, who is, has brought to us this evening some exciting, really industry-related wearables. And we have Pauline van Dongen, fashion designer, who has collaborated with Freedom of Creation to design some 3D printed works. I hope that you take the opportunity at each presentation to interrupt, ask questions, and engage with the presenters. And without any further ado, I think we should move forward to the very first presentation, which is Emily Crane. Emily Crane is apparently her friends have named her, a materialologist. Every time I say that word, I think of someone who can predict the weather, someone who can make materials, and someone who can invent things. She works at the intersection of food culture, and she combines molecular cuisine with material experiments. Essentially, she's cooking textiles. That's what she's doing this evening. She's been working with the studio Nancy Tilbury, who is quite well known for the Phillips work, and she completed an MA at Kingston University in London, where she still collaborates. Emily is doing a kind of performative engagement with materiality, and I think it's best to just give the stage to her to begin her experiment, and then we'll have an opportunity to ask lots of questions afterwards. Fantastic. Thank you very much. Now, I'm sure there are many questions and hopefully a mic for Emily as well. But let's just share it for now. This project is called Micronutrient Couture. And what instigated your interest in combining food with garments?
I did a very interesting project called Zero, which was sort of questioning what would a fashion practitioner do with zero resources. I spent a lot of time looking at different materials that were in my day-to-day life, and was one day sat in the bath, as one does, and saw how beautiful the bubble structures were within just a standard bubble bath. I started to ask questions about how this material could be used, what it could be used for, and what processes the actual material could go through to prevent a new material.
And what kinds of materials exactly are you using? You've described them as food byproducts and as these materials being edible. So can we eat everything on this table?
All the dried samples that are pre-prepared, you can definitely eat on the table. I wouldn't necessarily advise it, as they've been through a few exhibitions by now, so maybe not quite ready for eating. But all the ingredients are very, very edible indeed.
You've also brainstormed with the chefs at Fat Duck, a very famous molecular cuisine restaurant in London. And why would they want to meet you, and what did you talk about?
I kind of contacted them on the basis that I wanted to learn all about edible bubble solutions, really, and edible foaming agents. So I rocked up and chatted to them in sort of pink wellies and a very beautiful frock. And they're like, but you design fashion. What are you doing here? And I explained to them, well, I have this urge to question and provoke about the sustainability of our current fashion cycles and how throwaway fashion is, I feel, not the answer. And to prevent, well, my aim is really to prevent fashion ending up in landfill sites.
So will we see an increase of more organic materials, such as the ones that you're using in fashion, do you think? Or will we begin to eat our clothing at restaurants?
I certainly believe that there's a huge trend for sort of biocouture. I think it's very, very interesting what people are beginning to come up with, and some of the very outstanding designers are beginning to create.
And you've told me that your recipes are a secret. So how do you plan on disseminating this practice that you have?
My sort of recipes and ingredients I like to keep very close to my heart, and that way they're always a surprise. It's always very magical. So I've always seen that, you know, it's a very do-it-your-own process. So a recipe is sold with a kit, so it's very science and molecular. So add so ever many milliliters of X plus Y equals one bubble dress.
Any questions out there? I'm sure there are. I think there's a microphone that can go into the audience, or I can just come to you. What else do we need to know about Emily's practice? Any throbbing questions? Well, I wonder if it's actually, oh, wonderful. Anik?
Emily, how do you deal with the ephemerality of a work? What is the importance and the relation you have to works that disappear almost immediately after they are done?
I feel that transient materials are very interesting because they very push towards our current fashion cycles of a constant new. So the fashion-obsessed shopper that is forever wanting a fast fix and a new dress every week, a transient material that can be melted down, reworked, reset into a new dress each week, actually has very real sort of precedence with our current fashion cycles. How's that? Yeah.
Any other questions? How has the, I have lots, how has the reaction of the fashion world been to what you're doing, the kind of research that you're doing?
Some have been very interested, of course, with the materials. It's a new trick is always fascinating, but some people think it's a bit far out, and I have to explain that maybe it's just a trend, that trend forecasting might be the way forward, and that really I'm playing with materials and questioning and provoking rather than, at the end of it all, presenting a real fix.
And a final question. How does it feel to wear bubbles?
It feels great.
Great. Thank you so very much, Emily. Wonderful. So, our second presenter Carole Collet is as she's called herself, a creative ecologist and explorer in the field of textile innovation. Not only that, she's course director at the MA of Textile Futures and reader and deputy director of Textile Futures Research Centre at Central St. Martin's College of Art and Design in London. And she's brought a number of exciting, speculative, and very tangible designs from her current researchers and students. It's work that's just been finished, I hear, a week or two ago. And she's going to walk us through some of the research that's happening in her institution, an academic perspective, as well as a perspective which can be applied in different industries and research. Carole.
Thank you. So this is the work that I want to present to you, which represents what we do in the Textile Futures Master's course at Central St. Martin's. First of all, I've got a little presentations to explain a little bit more about the ethos and the spirit and the philosophy behind what we do, how we work, and why we work this way. And then we've got 4 of our current students' work presented here, which we can go over together with Valérie. So the course is set up really to question what textiles is, what textiles can be, and we don't have a formula for that. We're very much interested in thinking about it as a skin, as a surface, as a smart material. It's an architectural solution, it's a cultural heritage. And we're very keen to look into textiles in terms of smart, sustainable, ethical, and poetics. These are the key words that drive what we do. We're driven by research and by a sense of inquiry and by really trying to explore and interrogate materials, technologies, and ideas of the future. This is a student, Elisa Strodzik, who finished 2 years ago, who simply wanted to question, can wood be a textile? So in the context of looking at future fabrication, clothes without clothes, can a textile be a wood? She was awarded several prizes with this, amongst which the Young Designer in Germany. We're looking at technology and how it influences the way we design, particularly when you have to start working with materials that move and respond, materials that are made of programmable matter. This is the work of Ellen Ng, who finished with us last year, who looked at shape memory alloys and shape memory polymers, and combined with jacquard weaving and laser-etched wood surfaces, she created architectural surfaces that moved and responded to the environment according to heat and humidity levels. We work in relation to biology. This is Marin Sawa, who graduated last year, who looked into questioning whether we could design living systems. This is what she calls algarium. They actually are proposals for a form of textile architecture using algae that will clean up the air of your home, of your space. Those algae change color the more they absorb CO2, and you can see when they turn purple, they've actually been well fed and cleaned up the air. So she's looking at developing these algariums that clean up your air, but actually are made of living organisms. We work a lot to provoke, a little bit like what Emily was saying. We provoke, we try and forecast, and we try and sort of probe what the future could be. A lot of industries come to us to try and question what we do, how could we do it. And I wanted to briefly show this. This is a project we did for Nissan last year. They wanted us to think about what could sustainable mobility be in 2080. And this is one of the projects. We look more and more, and you'll see on the work on the table, we look more and more how biology is fusing together with design. For me, the future is very much inspired and influenced by what can be done in biology and nanotechnology, and when both can be combined together. This is a proposal of a prosthesis that moves and morphs in relation to the way you record your emotions. And so it's looking at how our body can embed data in the future. We do other strange things. This is one of the projects I've started working with together with Foam in Belgium and Bart van de Put, an artist based in Belgium, who came up with this idea of edible photovoltaics. And we started working around looking at exploring how we can design edible food that actually operate and function like a photovoltaic cell. And we did a test with some of our students. We made 100 photovoltaic cells with food. produced 0.01 volts, so we need to improve on that one. But this is very much again looking at how we can look at future of energy. In my work, I look at synthetic biology, and I'm looking at developing and growing hybrid plants that can produce lace as opposed to fiber. And I'll show you a bit more now. This is the ethos and what sort of inspires the course. And we've got 4 students here. This is Laura, who is looking at working with 3D printing, and it's great to have freedom of creation over there, because she's looking at working with that technology, but trying to make it become closer to the body by combining it with very low-tech, traditional skills, like embroidery. So she's looking at combining 3D printed materials together with very traditional techniques. It's a fashion textiles collections. The work you're seeing here now is will be showcased in 2 weeks' time in London. So I only have some samples. I don't have the finished pieces here, but this is designed for the body. The work of Amy, the biological atelier, is this piece here, where she's also looking into the future, 2070, 2050 plus. She's looking at a traditional couture atelier that we know now, where you have a lot of people working, doing traditional embroidery, but she's looking at how we could combine that together with biological couture and looking at growing sequences, growing various elements. And this is inspired very much and informed by current development in science, medical textiles used for grafting, bioprinting, printing cells, printing living matter is now possible. So what does that mean in terms of textiles? That means we can start looking at printing living sequences, for instance. And so she's looking at using and referencing to these techniques to create a collection of biologically inspired luxury trimmings. And this is an example of the biopin, which is here. And this would be, some of you might be doing some fashion or some couture. You already probably use your pins, in a little cushion. This is a biopin that would actually grow the pins over time. And when the pins are ready, they fall off, and they actually become what you can use to graft skin. So they're biological pins. This is Priyanka. This is the cookbook here, and you're welcome to come and look through the cookbook. Priyanka wanted to look into how nanotechnology can challenge our future. And nanotechnology is a very abstract technology for most of us. It's hard to understand. It's such a small scale. So she wanted to bring it closer to us by looking at something we all know, which is a cookbook. She's also used egg, which again we all know. So these are a whole series of recipes for egg that make comments on what nanotechnology can enable us to do in the future. She's done a lot of work with probing, really looking into how you can visualize what we can't see. And I would really recommend that you come and see the book and see the recipes. The last project, Natsai, which is over there in that corner, is looking at what she calls post-humanity in the age of synthetics. This one starts to bring a lot of ethical issues. And this is a map where she's looking at trying to locate her project amongst the sort of science technology timeline, where you're looking at the age of ubiquitous computing in the 2000s. And she's now looking at the age of scarcity, and she's positioning herself in a post-scarcity era where open source digital biology is possible. So you all understand open source. What if you can now use programs like there's one called BioBrick, and can you actually program biological matter to actually change yourself? And she's looking at cosmetic issues. So what we know as tattoo and piercing now, could it become that you actually biologically engineer yourself through open source technology to change and morph your appearances? So she's proposing that you could also look at morphing in response to environmental issues. If, for instance, there's a too high UV level, you could suddenly grow more hair to protect yourself. And all of this could be done through injection, various creams. This is informed by talking to biologists and futurologists, and she's actually worked in a lab to try and understand the protocols of science to see how far it could be stretched. And she's also working developing various bacterial samples. She's currently working on developing a genetic first aid kit. And that will be it for me.
Wonderful. Thank you very much. And perhaps now we could look at the samples, but I have a quick question first, which is, tangibly speaking, if the couture atelier is becoming a laboratory, how does that work in a sort of everyday perspective?
Well, this is the question we're asking, because I very much think that scientists are in a process of becoming designers, but designers need to learn about scientific protocols as well. I think the future is much more about teamwork. I don't think you can, as a designer, become a scientist or a scientist become a designer. I think you need to work together at the same stage, not one after the other, to develop interesting work. But I think that's changing the perspective of what could be a designer and how we can create and generate new ideas in the future.
I know that there is a process of unlearning that your students go through, which is that they go through a boot camp, a survival boot camp, where they're sent into the woods with nothing, and they must learn to survive. And this is the very first thing that is done at Textile Futures in order to unlearn our relationship with nature. Can you tell us a bit more about this?
Yeah, we kept it quiet for a few years, but I think now the word's gone around, so we can talk about it. One of the key aspects of our program is that we are very keen to explore sustainability and how we can make our designers become much more aware of their responsibility. So on day one, we put them in a bus and we give them bamboo, plastic, gaffer tape, and we take them to a campsite by the sea. It's in October, which is rather cold in England. They've been warned they have to have warm clothing, but they have no idea where they're going. They don't know that they'll have to build their tent and survive the night. And that's the best way to learn about the consequences of bad design. If you haven't built your tent properly, you simply don't sleep. And that's a good way to learn. But it's also a good bonding strategy when you start, so that we have roast and we have barbecue and we do all of that. But it's one way to kind of engage with learning by having fun, but also learning that if you do something wrong, there are consequences.
Sounds fantastic. Perhaps, can we look at the samples one by one, just to be able to speak to them a bit more in detail? Could we pull them out? I don't know, is there someone who can? Thank you, Alex. So this is Laura's work, and perhaps you can tell us a bit more about it.
Yeah, these are just samples because I couldn't bring all the finished work. But she looked at pseudo samples. She looked at how she could simply integrate the 3D printed samples together with textiles, whether they're folded, pleated, embroidered. And you can see those are simply a reference, different techniques that she's pursued before to explore how she could integrate it on the body.
And how do you think that traditional techniques, such as, I know you work with lace, how can they be integrated into this sort of future-forward look towards materiality?
In her project in particular?
In hers, and I know that also in your own work in BioLace, there's an interest in a kind of revival or revisiting traditional practices in textiles.
That's something we like to do. We're very much interested in looking in the future, but we don't want to forget our past. So some of the workshops we run, we, for instance, could run a traditional lace workshop, and the following week we'll run an Arduino workshop. So that's the process of unlearning. So we expose our students to very different kinds of experiences, so they don't forget about the beauty of craft and the value of making, but that they can engage with very new technologies as well. And then it's up to them to see how they want to confront them, or perhaps sometimes choose one or the other.
Do they engage with scientists the same way?
They do. I can't show it here, but actually, if anybody's interested, I have some more on the computer I can show you. But we every year run a project with scientists. We have a partnership with the Medical Research Council, and we have a project. This year we worked with synthetic biology, and we looked into, we bring scientists at the designer's table. They come and they brainstorm with our students. We did a 3 weeks project where we explored the meaning of synthetic biology in terms of future fabrication. And we looked into producing various animations that could stage what can be done when you start to fabricate with synthetic biology. And this was done with brainstorming conversations with scientists and a final crit again with a scientist. So there's a constant loop and a feedback. We also have students like Natsai, who's actually gone straight to work in a lab to actually experiment hands-on some of the protocols. The Algerium was also, Marine went to a lab to learn about how to work with these algae, how to create a living environment for them. So we do encourage those who really want to work with scientists to actually go in the labs and work with them.
how are the aesthetics engaged in this kind of practice? Because I imagine that there's a strong scientific push for this to be ecological or to be somehow, scientifically beneficial. But is there still a concern for an aesthetic outcome?
That never leaves us. The aesthetic is always there, always has to be there. I think if we propose a future which is not desirable and not engaging on a human level, there's no point even going there. So aesthetic is there, and I think what's interesting for us is to have an iterative process between the function, the performance, and the aesthetic aspect of the work.
Wonderful. Can we briefly speak to the other works that are here?
Well, these are samples where these are what we would call probing. This is really looking at trying to propose materials that obviously don't exist yet. Both Natsai and Amy looked at 2050, 2070. And so they are trying to use today's materials to project into what could happen in the future. So these are samples of some of the skins that you could actually grow on yourself. And this actually very much brings issues of aesthetics. We had a whole debate around aesthetics. Is this desirable? Is it not desirable? If you look at some people wearing tattoos or piercing today, some people find them beautiful, some people hate them. And so it's starting to question the level of what cosmetic surgery could do and how far could you go when you create that sort of subculture of open source biohacking. And so those are different probes of the skin. You've got a pin cushion over there and various sort of trimmings, bio trimmings that are suggested by Amy. And the cookbook, I think the best is if people come and see and look through it and actually read the recipes, because it's a bit hard at a distance. And this is a catalogue that we produce every year. This is last year. We're about to produce this year, but it's not published yet. If anybody wants one, just give me your cards and I'll send it to you.
Any questions from the audience before we continue ahead?
More a question on scale. Do you have students who bring this up into an architectural scale?
Actually, yeah, I'm particularly interested in textiles and architecture, and I collaborate with CITA in Denmark. And I have a PhD student who's based there who's looking at electroactive and energy harvesting materials for architecture. So scale is very much important in that case.
And the students in those projects start to collaborate with architects, or for example, to line up a little bit with your question is, of course, I'm trying to imagine how is lab organized in going into this research? I understand it's more one-to-one, so students go to scientists, they work with that, but what does it mean for the lab in general? Because I guess there's a lot of knowledge that can be disseminated later on to the next generation. There's certain principles that are coming back in the practices that are evolving more or less in the lab.
You mean our lab?
Yes, specifically
yeah, we try and
your lab.
archive as much as possible the work we do so that we can showcase that to the following group of students so they know what's been achieved, therefore that they need to raise the bar a level higher so that they don't repeat what's been done. But when it comes to working with architects, again, it depends because it's a 2-year program, and the second year, the students decide what they want to do. Some will go in fashion, some will work with architects, some will work with scientists. So each of them has a particular path. We don't impose a formula on our students. It's up to them. And some of them, like Laura, works very small scale, others work very large scale.
And the validation system for the students, how does that work? Is that a kind of a classic structure that it's in, also within the school?
Yeah, it's a master's degree. It's a 2 years. They have an exam in the first year and an exam in the second year. And they end up with a master's in textile futures.
Are there any other questions?
I'm curious how you deal with this, this tension between work which is inspired by biology, so it's more biomimetic, versus work which are actually using biological material. And the question that Alex brought up about scale is, I think, kind of the key to that. And I'm just curious how you work with that tension.
Well, actually, you've said it very well. Biomimicry and biology are two very different things. And some students look at biomimicry and at mimicking natural principles. And some students look at biology, which is actually working with biological living matter. And they are very different kinds of projects. Biomimicry is often referenced to in a context of sustainability, but you can produce biomimicry inspired, like Velcro, for instance, is biomimicry inspired, but it's manufactured through chemicals and it's polymer based, so it's not sustainable in itself. So we make a clear distinction between the two. And I mean, this is, again, up to the students to pick up what they really want to do. We try and propose different different paths, and then they choose which is most suited to them.
Carole, thank you so very much. I invite you all to come and consult the works and consult the Nano Cookbook, which is absolutely beautiful. Thank you again. Yeah. So, next stop is here.
So I guess you're still here tomorrow morning? Right. Okay. Then I'll give you the book later on. Thank you. Very nice work.
All right, so our next guest is Christien Meindertsma. She is presenting a project called the One Sheep Sweater. Christien is a Dutch designer. She studied at the Design Academy in Eindhoven, and she runs her own design firm since 2003. And she's also known for, as she describes it, exploring the lack of knowledge and possibilities in working with materials which are usual but not well known in their sort of new form. So can you please, to begin with, tell us about the concept of the One Sheep Sweater?
Yes, this is actually, the concept came from my graduation work in 2003. Graduated from the Design Academy, and I wanted to make a product that would actually tell something about itself. So most products have a nice marketing story that tells a beautiful story, but it doesn't say anything about how it's made or by whom or what it's made of. So I thought to make sweaters that would be made exactly from the wool of one sheep. So a big sheep would make a big sweater and a small sheep would make a small sweater. But I thought it shouldn't be like a handcrafted project. It should be something that's machine knit. And that's where the trouble began, because it's virtually impossible to make a yarn that is even enough to knit on a machine. But that comes from one sheep as well. So, well, I managed to create a few sweaters like that around 2004, but then I kind of gave up. But last year I suddenly saw an opening because I found a small spinning mill in Belgium who was new. So that was very sort of nice, a new development that there are miniature spinning mills. And a very good programmer at the Textiles Museum who could help me program a sweater. And a farmer who owns 25 merino sheep. And they're like a new flock living in Aarle-Rikstel. And for anybody who knows anything about wool, to make clothing you need very soft yarn, and merino are very rare in the Netherlands. So with those three elements, I'm now trying to make a collection of sweaters. And what you see here is all still prototypes, but these are the first good yarns. So this is exactly one sheep. And I cannot move this, but the sheep will eventually come.
So essentially, just to get a sense of an overview, you are a mediator between what perhaps exists already on a farm, which is there's already an existing flock of sheep, and you are trying to sort of take this basic material, apply what is otherwise known as the 1 mile diet, something that's local, and translate that into something that is as high-tech as possible. Why is that so difficult?
Because, well, I'm kind of trying, what you're saying is right. I'm trying to be the connection between these things that seem really logical, but actually the wool in the Netherlands is more like a waste product, because we don't actually have industry to use wool anymore. So I also make other woolen products, and it took me, so here you see the flock when they were just shorn and all their balls of wool. But to come back to the wool and waste thing, sheep in the Netherlands are held for their meat. So if there's nobody to do anything with the wool. So with my other projects, I try to use that Dutch wool, because otherwise it's just used in like in houses or behind walls. And it's basically, it costs a farmer more to pay the person that shears the sheep than what they get paid for the wool. So they actually make loss on wool.
Okay, so it's almost considered a kind of garbage.
Yes.
Now, Why is each sheep special somehow?
Well, what's kind of interesting is that the quality of the wool depends on the quality of life of the sheep. So if you look at one strand of wool from a sheep, when the sheep would have had a bad week, or you leave it out in the rain or something, after you shear the wool, if you pull it, that would be the weak spot. So that's where it would break. So the yarn tells exactly how good the sheep's year was, exactly. So that's an interesting thing, but it also makes the spinning very difficult because they are all different. So in the spinning mill, each fleece that they have costs a lot of effort to spin. So,
is it a kind of political provocation that you are doing this? Because you've only produced, we have 2 sweaters here, so it's not a large output. No. And it's clearly much more complicated to make this on a 3D knitter than it would be for someone to just knit it by hand. So what is the statement that's being made through this work?
Well, I don't really see it as a political statement, but I see it more as a way of producing something locally, because you don't really need any handwork. So if you want to make something in the Netherlands, most things I make are super expensive because it costs Dutch hour payment. So I thought maybe a way to make a product in the Netherlands is to make it, well, completely machine made. So this machine actually knits the whole sweater in one run, so you can see it slowly. I don't know if anybody saw the Wallace and Gromit film where the sheep gets stuck in the machine and then the sweater comes. Well, it's kind of, well, I'm hoping it will become a little bit like that. So the whole sweater will fall out.
Maybe it's time to look at one of them, just to explain.
Yeah, so these are very sort of prototype-ish. The design will probably change a lot, but it's better to show the other one, because that's one I didn't do anything. So here you can still see they're all connected on the bottom. So this is just how it rolls out of the machine. And yeah.
Can we pass it around?
No.
No. Okay. But I have a question. How will I know that this sweater is so special? Because what it communicates from the outside is not really the process. And how isn't that a challenge in terms of using these practices and then having them be communicated so that the value is appreciated? Or is that not important?
Well, I try to explain the whole story. I mean, you get to know which sheep was the sheep that grew the wool. So, I mean, that's as far as how it goes. But I don't really feel like the product should should give that much information. It should just be a nice sweater.
I ask because there's some talk in industry as ways of finding or making people recycle materials more is to have RFID tags, so we could have some kind of knowledge about the provenance of materials. Yeah. We could better learn how to recycle them, and we could have a kind of more intimate relationship with where materials are coming from. Yeah. So I wondered if perhaps that would be something that would be of interest to have integrated into such a sweater.
Yeah, but that would be interesting because that's already happening in the wool world, actually in New Zealand and Australia. But that's interesting if you're talking about larger scale farms, I think. But with this one, I mean, if you buy the sweater, you already know it's that farm in Aarle-Rikstel, and you can just go there and visit the sheep. So, and like a digital tag would be a bit odd for something so small scale, but for a larger scale, that would definitely be interesting.
Shall we open up for some questions? Well, I guess ultimately I wonder what is the next step for the project then when you'll knit it again in 3D? What are your plans for it?
Well, first I wanted to see if I could do this on a bigger scale, but now I realized that maybe it's just going to stay with this project and this vlog, because they're all different. It's a very difficult process to spin the yarn like that. So it's hard to upscale it, because it will always be a sort of very special one sheep related thing. So yeah, I'm doing a lot of other projects, and this is like a project that I started out with that I just always really wanted to finish really well. So once I've knitted the sweaters and people are wearing them, I think for me that's a good end for this project.
And how many will there be in total? How many sheep?
25. Yeah.
So, oh, yeah, I did have a last question. If I want to buy one, in terms of the actual sort of time invested in it, what would be the value of one sweater made through this process?
You mean how much time is invested in it? Or
well, what does it economically? What does it represent? If I wanted to buy one, and you know, we have textiles that are being produced the world over at very low cost. So hence, we go to H&M and we buy that really cheap thing, and it's not a secret. We know how these things are produced. So it represents more or less the value of it. However, if we switch to this kind of production scheme, what would be the monetary value? What would be a fair monetary exchange for one of your sweaters? I want to buy one.
Well, there's no price yet, but I don't agree on your idea about that the H&M sweater is very clear about what it costs, because the H&M sweater, for instance, costs 15 euros. I mean, if you calculate it, you would probably be willing to pay 4 times as much if you think about spinning the yarn, you know, finding the plants and the whole process. So I don't really agree on that. I think it's very shady where these...
No, what I was thinking was I heard that sort of like a designer shirt costs about 75 cents and you pay $50 for it. Yeah. And so I'm thinking that this probably costs $400 in terms of time and effort and all the people. I don't know. I mean, if we were to sort of think of it in those terms.
Well, the costs would literally be to shear a sheep, to spin the yarn, which probably takes about half a day, and then to knit the sweater, which costs an hour. But to be really honest, I'm not sure exactly what the price of the machine in the Textiles Museum is, and so I can't tell you this exactly what the price is.
And any other questions from the audience? Great.
Thank you. Okay. Christine, do you think it would be possible to extend or enhance the knitting machine so that it selectively dyes the thread as the sweater is being woven, and then it builds up a picture of the sheep that the wool came from, so that you can identify the sheep with the sweater later?
I think that should be possible, but it would probably look a little bit not so sharp.
Yeah, you get a low-res sheep.
Yeah,
yes,
but it probably be, that would probably be possible.
Because you can tell the difference between the sheep from their faces, I'm sure.
No, but you can. I mean, if you, I mean, it's very hard with this light. But if in a like daylight situation, if you see them next to each other, you really see the difference in texture and color. So even without the pictures.
Okay, so the picture isn't necessary.
Well, you know, no.
And one last question in terms of 3D printing. Do you imagine this technology to become more democratized, and that we will indeed have a future where we have a 3D knitting machine at home? Is this something that you...
Well, right now, the problem with this machine is that the programming is really hard. So that's why it took me so much time to find somebody who could program it for me, because there's just not so many people who can do that. So if there would be programmers, then yes. But right now, this machine didn't become a really big success because it was still easier to sew the garment together instead of programming it for it to come out as a whole. So I just really like this technique because you can translate a whole fleece into one sweater in one run. But I don't think economically this machine is not such a big success.
Great, thank you. Oh, one last question.
You were just mentioning that the sheep has a bad hair day, and the hair is that true with us as well?
Well, I think I think it well, I'm just sort of. I mean, if you eat, you can eat good food for better hair, of course. So your hair, it does say something about how you're doing, I think, but not so much as with sheep. You're welcome.
Great, thank you very much, Christine. Next stop in the middle. So our next guest is Giada D'Amaco, and she's from Grado Zero Espace. It is a design and research firm in just outside of Florence. Is that correct? Yep. Okay. Near Florence. And they're really doing very industry-ready types of wearables. So they're exploring what is the market for these kinds of new technologies, and they're developing them for real-life situations. So Giada has a number of exciting samples which we're going to look at and demonstrate and perhaps probe a little bit more into why we would want these. And also, I think what's interesting for me is to imagine these also in other scenarios, more artistic scenarios, for example, or what are other applications for some of the materials that you have. But perhaps to begin with, could you tell us a little bit more about what is Grado Zero Espace and how do you conduct your research?
Right, correct. Okay, actually we have more or less 10-year experience in product development. And since for beginning, we started work in a clothing company. We were research department of that company, and then we collect a lot of things, a lot of innovative materials, and so we decided to not focus just on clothing, but also in applying research in different sectors. So from furnishing to medical applications or military. And thanks to our collaboration with the European Space Agency within the technology transfer program, we was able to transfer that materials coming from space industry into daily life, for daily use. That's why just today I just bring some demonstrators of these technologies, some of these technologies. But yeah, again, we don't work just on a clothing sectors, but one of the main important things and one of the main objectives for us, as you already mentioned, we are placed in Florence, near Leonardo da Vinci town. We are very close to Leonardo da Vinci town, so we are very proud of our of our origin. And what is our aim is to bring technological innovation for maintaining and strengthen the textiles manufacturing know-how and culture, because in Florence there is one of the biggest textiles districts in Italy, and so we think this is one of the solution that we can bring to face challenges to be competitive and also to have something unique respect to the other product producing in other countries. So this is more or less our activities right now, and the vision that we would like to bring over. And
do you work with the designers, or do you also otherwise work sort of as a consultancy?
Correct. Yeah, we actually do consulting activity for different industrial domains, and also we do pool research in research projects. And so we are able to monitoring what happened and what could be, which kind of materials can be used in a future life. So, but as well as we are very linked to the industrial process. So we work very strictly close to the industry and to our client. Yeah. So.
Shall we look at some of the exciting samples that you have?
Sure.
Perhaps the first is the Orichalco shirt, and I
Yeah.
think we need to plug in a hairdryer and get it all warmed up. So what is shape memory alloy?
it is of course alloy. It has an external ability to recover any shape pre-formed and pre-programmed and return upon heated. So this is one of the example of the materials that it is already stiffed, and then we can just pleat it, and we can just modify, and then according to the just simply airflow, it come back to the originally shapes. So. Avalon. It is a name of our research project in which we participated. So we can modify this the wire, and then sorry, I put here. Back again, and the same technology we use to produce this shirt, which is the first product that we made, which is not real product, but just a demonstrator of this technology into textiles. It is it coming from 2001. So the idea. Probably too short, so maybe we need to. Okay. So the idea is to have a shirt that it is self-hardening. Now I can try with a hair flow, as you can see. You can pleat it and freeze it, and then with a hair dryer, is it possible?
I think everyone wants one of these. And
of course, we after this experience, we go ahead and develop something very thinner with the diameter, and then mix it with the other fiber. So at the end, the touch of the fabric, it is also even better. But, yeah.
Wonderful. Perhaps we can talk about the hydrogel jacket, and we can ask our volunteer, Ruben, who's right here, the fireman jacket.
Okay, so basically the main aim of this project was to create a thermal thermal comfort and moisture management system. Of course, the project it is a multiple layer structure, and the inner layer are made by super absorbent polymers. Which calls hydrogels, and then I can also demonstrate with the powder. And we put this kind of materials. We found a way to integrate it into a textile structure. Yeah, as you can see. While the first layer, it is made by a double aluminized fabric to reflect the ray. And then we have a spacer fabric and a thermal barrier, and then we have a double fabric coated with a hydrogel. So you can.
Yeah. Perhaps Ruben, can you hold the?
Okay, we're going to collaborate on this.
Yes.
For you.
So what is special about hydrogel, and who invented it?
Okay, the hydrogels mainly the first application was to recover the oil from the sea, because actually this powder, this is a polymer that reacts to a special liquid. So we developed this hydrogel that react to the sweat. so the specific pH of the skin. But it could be possible to react to different kind of liquids. Okay.
So what is its main function for a fireman?
The idea is to have to absorb sweat and to release to the other side, to the external layer, and creating a kind of a moisture management. It absorbs more or less 14,000 its volume, so it absorbs a lot.
40,000 times?
400. So as you can see, it becomes a kind of a gel, and then it absorbs a very lot of quantity of water, and it releases also in a fast way.
Where is it releasing? It's just releasing it out as it absorbs?
Yeah, it's like with the hair, it become again dry.
May I touch it?
Yeah, sure. It's a biocompatible polymer, so it is also used for medical sectors in a surgery. So it is a completely biocompatible material. So this is just one of the
what would be
solutions.
some other applications for it?
For the hydrogel.
Yep.
Actually, also in the cosmetics, and we have a lot of markets in that field. But one of the biggest issue that we working on, it is on thermal comfort. So for insulating materials from very high temperature to very low temperatures. Yeah.
And we can pass this one around. Yeah. People can touch it. Good. All right. So we have another jacket, and it has a kind of interesting way of interacting. And we'll just switch it around.
Right.
So what the particularity of tell us what the particularity of this jacket is.
Yeah, particularly is that integrate different solutions, the leather treatments, and also the smart protection, smart shock absorber materials. So,
can we have a volunteer who would like to hit Ruben? Oh, a very weak volunteer. Oh, but apparently you must do it No,
Are you sure?
There is not much to fear because apparently the impact will determine how resistive it is.
So here, you're not here. On the shoulder.
Yeah. We have insurance, right?
Okay, this technology, which is called V3O technologies, comes from this intelligent molecules structure, that it becomes stiff proportional to the speed of the impact. So at normal condition is very flexible. It could be replaced the normal protection, for example, for motorcycle. But as soon as you could also try, but you could try here.
So, you feel?
But
no?
very speed. You need to do it.
You okay? Yeah. Okay.
A little bit. No.
Do you feel the material changing in the jacket? Yeah. You do, and does it sort of retracts or just?
The first time, the faster you got, the better it felt.
The better it felt. Excellent.
Right.
So this is a motorcycle jacket, but what else could we imagine using this kind of smart shock-absorbing material?
For different applications, mainly for workwear also, sportswear, but also workwear, or to protect any kind of fragile object. So like a suitcase or something like that. But there are so many applications. And also we put also a patented system, which is a leather treatment that protects from the alkaline environments, so marine environments, and from water, from UV rays, and so on. And so, this particular treatment will be able to, with this treatment, we'll be able to reduce the thickness of the leather, increasing the mechanical properties, and maintaining the good flexibility and elasticity, which is in a leather. It is very important to have a very elastic and flexible materials.
Okay, one last hit with the hammer, and then we do the next one. I promise, I think we can play with it after, right?
Okay.
Okay, all right. So we've got one more piece, actually two that we're presenting. Thank you, Ruben, for being our guinea pig.
Thank you.
This is a product called Relight.
Relight, yeah.
Relight.
It is a fabric, glass fiber fabric. So it is a normal fabric, but it emits light. So it's a fabric light bulb. It contains, it is a fabric which with the electroconductive polymer coated on top. It is a multi-layer system. And it is a cold light, and the particularity of this technology is that, of course, it's a fabric, so you can also manufacturing as a normal fabric. So you can sewing, you can cut it even here in a lighting area, and it continues to emitting light.
So I could, in fact, cut a pattern of an entire dress in this fabric, and it would still continue to emit the light.
Right.
However, I see that it's plugged in, so that's not super practical for garments.
Yeah,
so
not for.
So
yeah.
how do you imagine that in the future to be commercialized?
Okay, mainly, actually, we are commercializing for other sector, not for garment, for accessories or for yacht. Or for automotive, we develop interior design for Alfa Romeo. And so we, of course, according to the area, to the lighting area, we are able to reduce also the batteries. So here we can I plug it on the wall, but it's possible to have a portable power source. And even with the solar cells, we can also replace this kind of plug. So, yeah, potential applications are are many.
And the final piece that you have is this carbon nanotube tennis racket. So what is special about making a tennis racket out of carbon nanotubes?
Yeah. Nanotubes are made of carbon atoms and carbon bonds, and it provides very strong materials, and also respect to the composites. It's here it is not composite but just a resin with carbon nanotubes additive inside, and at the end you can have a tennis racket very light and stronger. Respect to the commercial one. So the applications are so many. Here just an example, but also in automotive or other sectors, in accessories also. It's gonna be very growing, this kind of research area also.
I think the public is invited to test out the tennis racket when we finish up. So we'll do that afterwards.
Here is carbon nanotubes inside, but it's into the composite also. So it brings so many resistance, maintaining good flexibility and also lightness, of course.
Are there any pressing questions for Giada?
Okay.
So you're invited to come. Can they try out the clothing? And
right.
yeah. and all of the various materials. So thank you so very much for your presentation. Great.
Thank you so much.
So our next presentation is, we're moving everywhere, and we're coming this way. We now have Pauline van Dongen. She's a fashion designer who put out a recent collection called Morphogenesis. And through that collection, she also developed a 3D printed shoe, which was done in collaboration with Freedom of Creation, who has their 3D printer set up over there in the corner. So Pauline is going to give us a short presentation on her research, why she decided to engage with 3D printing technology, and what the future of these various technological practices, such as laser cutting, 3D printing, how they're becoming popular in the fashion industry. Pauline.
Thank you. I graduated from my bachelor in 2008, just to give a short introduction, and I continued into a master at the Fashion Institute Arnhem, where I graduated in July 2010, and after that I continued working on my own label. These 3D printed shoes were developed for my graduation collection, Morphogenesis. I hope the beamer will work to give you more images of the whole process. Well, I'll just continue with that. During my master, I was offered a shoe design course, and this was really an eye-opener for me as a designer. It really triggered me in very unexpected ways. Especially the rigid aspect of a shoe, it made me develop even more an architectural and structural signature, which you now still see in my clothing designs as well. I really like to work as a researcher. I like to work with new materials and innovative techniques. Well, there it is. Thank you. We'll skip this one. Here you can see the first shoe that I designed and made myself. And at that point I also learned how much time it takes to develop a shoe by hand with traditional craftsmanship. Here's a picture of the shoes. With designing shoes and also with designing clothes, as I told you, I look for new materials and innovative techniques. I think innovation really advances our idea of what fashion could be in the future. And I think since fashion is always rapidly changing, it can incorporate the newest developments. This shoe was designed, as I told, with my collection Morphogenesis. With Morphogenesis, I started out with a fascination that I have. I'm very fascinated by the way people behave in their surroundings, the interaction that they have with their environment, the relation between human and their surroundings. And for this collection, I researched the space that's the closest to our body, the space between a body and a garment. And with certain materials, I wanted to emphasize on this void. I searched for new materials that I could use, which is, for instance, the synthetic crin, braided nylon, which acts very sculptural on a body. When I was working on it, I always start directly on a body, making drapings and moulages. And it actually made me feel like a sculptress myself. Here you can see some of the process. I was inspired by the artist Anthony Gormley, who also works with the space around the body. And here you can see some of the first mock-ups. I also found a very interesting material that's been used in hat making a lot. It's called bunto, and it's a woven wood fiber from the Philippines. And it may seem quite rigid from a distance, but it's actually very flexible and moves very organic around the body. And to me as a designer, for me it's very important that the body is what gives the garment a certain shape and not the other way around. I started out with designing the shoes, and the first problem that I had is like, how would I be able to design 10 pairs of shoes, make them by hand within a limited time, and also designing the whole collection, of course. And someone told me, like, why don't you buy these prefabricated heels? And well, I Googled them online, and I was really devastated by the ugliness of it. So I thought I have to find something else. And that's how I got in touch with Freedom of Creation, who will be presenting later on. They're very experienced in 3D printing, and I came to them like with the idea of designing completely 3D printed shoes. And I didn't know if it was able, if the technique was already there to do it, but we just tried it out. And it turned out that I could go even further with the whole design, because with 3D printing you have endless possibilities of constructing the shoe, and you can make shapes that you wouldn't normally be able to make by hand. Here you can see also a series of the final result. With these shoes, I've translated the organic and sculptural feel of the collection into a heel, which is also very organically. Models have been walking on the catwalk with them, and someone is showing them now, but I must say they're not comfortable yet, not enough, because the material is still quite rigid and has some limits. We've tried to make one sample in a rubber version, which is very flexible. And ideally, we would combine the rubber and the polyamide to make a structural, functional heel and a more soft, wearable strap. The technique is there already, so.
Is it just trial and error in terms of the material to know?
It is. To me, it is, because I had limited knowledge of the technique before I came to Freedom of Creation, and they're still developing a lot of the materials and a lot of the printers. So there is a printer now that can print 2 materials at once. So, but it's evolving. So, yeah. Well, they've been exhibited around the world. They've seen more places than I did, so it's very nice. Do you want me to continue on what I've?
Well, I have a few questions concerning the shoes, perhaps before we move on to what you're working on. The first of which is, other than the time constraints, what are the advantages of 3D printing a shoe?
I think, like I said, you have endless possibilities regarding shape and construction and application. Things that you wouldn't normally be able to create by hand, you can with 3D printing. And also, if you want to create a limited series, it's way more. I mean, it's still an expensive technique, but it's cheaper to do it with 3D printing compared to like making an injection mold and having to produce thousands of pieces. So, and I think also for the future and for regarding sustainability, it's very nice that you work with 3D files, which you can send all over the world, and you won't have to, you won't need as much transportation as you would normally.
Can the fabric that they're made out of be recycled? Is it a sustainable?
This one can't. It's a polyamide, but there are materials in development that can be more eco.
And it seems that they're quite challenging to wear. Is it just the height, or is it the feel of them?
It's a combination, since the material is very rigid, and the strap, it really strains your feet. So that's one of the things why it's not comfortable. We try to put some springs in here, which is also printed at once. And also the height, of course. They're very high, so it's a challenge to walk on them.
And how did the collaboration with Freedom of Creation, could you sort of take us through the process of what are the steps to the end product?
Well, I just called them at first, and they were very enthusiastic because they had been designing some shoes in the past, but never really got to the point of making a whole shoe printed. And so they immediately want to support me with the project. And I showed them my first sketches, and Janne, the owner of the company, told me like, well, you can go crazy. I mean, this is not, you're not using the technique as optimal as you can, because you can do anything with it. So I went on sketching further, and then I eventually came to this design where I think I did use the technique as much as I could.
Now that you know more about the potential of what can be done with 3D printing, then would you imagine these differently? Because it sounds like perhaps your first idea was limited in terms of what you knew about 3D printing. So what else could you imagine now that you've worked more, now
regarding
that you've worked in it?
A certain product? Or
regarding shoes,
regarding
for
shoes.
example.
Well, I was thinking more about clothing also. At the moment I'm making a wedding dress, which is partially 3D printed, which is also very exciting, and I think it's a very challenging thing to focus more on wearability and see how we can use structures or maybe materials that are more soft and more wearable, friendly to the body. So that's something I'd like to focus on with future projects with 3D printing.
Shall we talk about your future projects?
Yeah, this is my recent collection that I just wanted to show you very briefly. Which is inspired by space itself, how we see space, and how light influences our perception of space and can create illusions of 2D and 3D surfaces. James Turrell and the work of Anish Kapoor are always a very big inspiration to me. Again, I start out with the drapings and also the wood fiber that you see in the right swirl. For this project I went to several fab labs, most of you might know about them, where I could use a laser cutter. I cut all these different patterns in leather and silk and reassembled them into structures that appear to be three-dimensional and play with light when you move around them. I started again on making some shoes, and I had this idea of a layered transparent heel, which I laser cut out of perspex, or plexiglass, how you say. This was the first prototype, and it's always actually trial and error with me. I tried it on the model and it broke immediately. So I started on making new prototypes. Here you see an overview of some of the garments. It's again a play with light and volumes. These are the pieces, the end result. And at last, you see the shoe design. I made a construction where these layered laser-cut plexiglass shapes could slide in through the, how do you say, grooves of a wooden sole. So that's what I want to show.
So combining old and new.
Yeah.
Are there questions from the audience? From the fashion people in the audience? I think Wilco has a mic. Don't be shy. Practical terms? Well, just, oh, there we go. Who's gonna, we'll let Wilco.
Is it easy to adjust the design to the size of the foot?
With the 3D printed shoes, you
Yeah.
mean? Yeah, that's also something that's very interesting. I think in the future, also designs like shoes or maybe clothing can be easily adjusted to individuals. When you, for instance, 3D scan a body or a foot, you can like mold the design in your 3D program according to that shape, which is something very interesting also for ergonomics and wearability. So.
And I asked the same question to Christine. I'm wondering if you are designing these for a future where we will indeed be able to print our shoes at home. Do you realistically anticipate this, and how would you prepare for it as a designer?
I think in the future, I mean, I think 3D printing is the technique of the future, and eventually people would have their printers at home. I mean, people are already making their own printers and printing little things, but I think the difference that will be set is that you still need a certain expertise and focus on quality and wearability, and that's where maybe designers are still coming in. I mean, people have their printers, their normal printers at home, but if you want the best result, you go to a professional print shop or print office. So there will still be a difference between having your printer at home, I think, and printing a more professional piece.
So we'll still need designers, and we'll still need good
I hope
technicians
so. Yeah,
and professional machines.
Yeah.
Thank you so very much, Pauline. We'll move
you
on
too.
to Freedom of Creation, who can tell us a bit more
Yes.
about 3D printing. So, for our final presentation, for those of you over in this corner, I think we need to be. Our last presentation is Brian Garrett. Sure. He works at Freedom of Creation, which is, as we just heard, the company that helped Pauline develop this incredible 3D printed shoe. And he's brought with him today a printer and many different artifacts, which designs, products which have been made with 3D printers, not this one per se, as I understand, but he's going to tell us a little bit more about the process of designing and the more technical side, perhaps.
Yep. So at Freedom of Creation, we're one of the first pioneering companies to go from design to 3D printing. And so everything we make on a computer, we draw it in a 3D program, and then we send it to the printer, something like this. And it starts actually making this 3D file into an object. And the way this happens is, imagine if you have a 3D file, you can slice it in very thin layers, and then you can just take a thing and go extrude layer by layer by layer until you have your final object. And that's basically what you're seeing here. We're making the V2 logo, and it's just building up layer by layer by layer until finally it's going to make this thing.
So I've seen some things on your website that say gold. And what are other kinds of materials that are being experimented with in 3D printing? Because I think the perception is that it's a rapid manufacturing technique which doesn't really translate into precious metals or precious materials.
Mm-hmm. Yeah, the better question to ask is which materials can't you 3D print? Because these days you can print paper, you can print plastics, you can print metals, rubbers, ceramics, gold, silver, pretty much everything. But each material and each technology has its limitations and its different strengths. So metal is of course small sizes, and plastics is bigger sizes. So that's one of the main differences.
Can you take us through some of the objects that you brought here today?
So one of the first designs Janne made is this dress, and it's made up of a lot of rings, and that's what we call textile. This is a design from 2005, so it's already like 6 years old. And believe it or not, this dress comes out of the printer in one piece. So it's modeled on a computer, and all the rings you see are modeled in such a way that they don't actually touch each other in 3D space. So if you print this thing, then it comes out as one piece, and it's ready to wear. And what's always quite striking to me is that we took this design back in 2005 to the big fashion brands, and we presented them, and we told them, like, we can make you a dress that will blow your mind, something that you completely can't imagine. We can print you a zipper, we can print you buttons, we can print a complete dress. And the only thing they ask is, okay, what's the square meter price? And so they completely didn't got the whole clue of 3D printing. So that's one of the first things. And then in similar textile field, we have the punch bag, which is also textile based, but it has a different pattern, which makes it, on one hand more interesting, but also a bit more flexible. And the funny thing about this design is that, apart from that it's in a MoMA, is that you can't take it on a plane, because it's officially seen as a weapon, because it has a knuckle duster as a grip. So someone bought the design someday and wanted to take it on a plane, and it was stopped by customs. So that's interesting. This is something else. This is so this is 2005, and it took us 6 more years to make it into a glove. And the reason is that the technology had to be more refined, but especially making the 3D model for this that's really quite complicated, and that's what took us like 6 more years and 10 minutes to figure out how to arrange the geometry in such a way that it will actually fit like a glove and not melt together like one big lump of plastic.
I see that each one has a different sort of ring shape or ring combination. So how do you work with the sort of textile design in that
I think
sense?
so far we have roughly 10 different textile patterns. And for example, this is called the Mobius, and then we have the, we call it the 4-in-1. So that's 4 rings who go into 1 ring, and the 3-in-1. And so we have 10 different designs of textiles, and they all have their strengths. So some are flexible, some are really thin, some are really, look nice, and so that's the differences.
Are these freedom of creation designs, or how?
Yeah.
Okay.
So.
And you've also created shoes with Andrea Chavez.
Yeah.
And so can you tell us a little bit about those, because I think they're even more challenging to wear.
Yes. So Andrea Chavez, a Brazilian shoe designer, she approached us, I think, about a year ago, and she already had this design, but she had no clue of how to make it, because it's quite a challenging form, and it cannot be made in traditional ways. So we helped her with making the 3D file and producing the nylon shoe. And it's actually, this shoe is being sold, and she did it quite cleverly, because she made half a traditional shoe, which goes inside, and half like state-of-the-art 3D printed shoe. So it's sort of a morph between new and old techniques. So on the inside there's leather, so you can actually wear it. And
What's the biggest challenge when you're working with designers?
Especially when we start to work with new designers, and especially designers who are a little bit older, the traditional designers who still think in molds, and we completely don't have those limitations. So we first have to sort of educate them and tell them, like, okay, you can make whatever you want, just let all the limitations go, and then we create whatever they need. And sometimes it's a museum piece, and the other time it's a campaign, for example, or a giveaway, or a ring. It can be anything.
And I was surprised. I think Joris went to your office, and so did I, and we expected it to be like a big factory with a bunch of machines. Where are the machines, and why are they not in your office?
The machines are everywhere. We don't own them, because it wouldn't make sense to own machines in this day, because the technology is changing so fast, and that if we would own the machines, we would have to fill them up constantly, and we would become a production company, and we want to be a design company. So we have connections with all the production facilities all around the world, and if we need to make something, we go either to Germany, or we go to England, or to the US, depending on which technique, which material, which finish, etc., etc.
And how much does that lab that you go to get these things printed in, how much does that inform what you're able to do? Is there, is the role of the technician or the environment in which things are being produced, does that also dictate the kinds of things that you can make, or the vision that you might have of this technology? For example, are you able to experiment in a radical way with the printers?
Yeah, of course. We work with all these engineers and the technicians, and they only think about, we have to make the finish on this product perfect, you know. You have to make the layer thickness thinner and thinner and thinner until you don't see the layers anymore. But what they don't think about is that maybe the layers can be part of the design, or maybe it's just part of the look and feel of 3D printed products. And what we do is we tell them, like, what we want is a cheap material, something that we can produce fast. And then they go like, okay, well, we'll look into that. Or sometimes they come with a new material, or a new finish, or a new way of printing, and then they ask us for input, you know, like, what can we make, or what should we do with this? And So it's, yeah, that's really interesting to be on the forefront of 3D printing.
But how do you situate yourself, for example, with the work of Emily and Carole, which is very experimental material? How can you see this kind of sort of experimental approach to materiality translating into some of the things that freedom of creation makes? Can we see a lard dress? Can we see a flesh dress? Can we imagine a kind of bio couture that will also be 3D printed? As we saw, one of the researchers with Carole, Laura, was experimenting with sort of traditional practices in 3D printing.
There's a couple things I see happening in the future, and that's the combinations of materials, be it 3D printing and other kinds of 3D printing, so metal and nylon and metal and rubbers. That's something that's obviously going to happen. But it could also be a combination of 3D printing, indeed, with fabrics and traditional ways of making fashion. So, yeah.
Or embedding circuits or network technology, or, I mean, I think there's lots and lots of potential there. So any questions from our audience to probe to Brian and the freedom of creation works that we have? Yeah.
It's a fascinating technology. I was just wondering about the energy consumption in the printing process. If you compare it to other traditional methods like injection molding, is it better? Or
I wish I could say yes, but I think at this moment, because if you compare 3D printing to injection molding, it's still in a very early phase. There's only 30 or 50,000 3D printers in the world, which is very little in comparison to injection molding, but it has the potential to be much more sustainable and energy efficient, and that's maybe not only in the energy consumption, but mainly in the fact that you can get rid of transportation, because you just send the digital file instead of having to ship stuff from China to Europe. So that's probably where the biggest energy save is going to be.
Hi, Brian. I was wondering, what software do you use to design the 3D prints?
You can use any software, as long as it's 3D. So from SketchUp to 3D Max, Rhino, SolidWorks. Basically it all works, but there's always some fixing involved. So if you're a good modeler, then you can use any software. But if you're a poor modeler, then we have a lot of fixing to do. And we'll also get it to print, of course.
Thank you.
So we have a special launch of something which Brian worked on, and some of you are in on it. But Brian actually designed this V2 club ring, which we are launching this evening, and you can purchase from Barbara. Lovely Barbara. We'll be passing them around. And maybe you can, before we sort of launch them out into the world, just tell us a little bit about the process of making this ring.
Yeah, so you asked me to make a cool ring, and the only criterion was to have the V2 logo. So what I did is I extruded the V and the 2 as into 3D space, and then I connected the V and the 2 together and sort of morphed it into a ring shape. So actually it goes from the V and then all the way back into the 2, and it's like one continuous shape. So that's it.
I think it's really cool. So they're €5. You can pick them up from Barbara. I think it's been a fabulous evening. I hope you feel the same and are inspired by some of the works and projects that have been presented. And I have many people to thank for this evening, first of which are the presenters for coming through and coming in with all kinds of fantastic work from all over the world and being so very articulate. Not to forget my sort of conceptual collaborators, Michelle and Pim, with whom I concocted this evening, so I can't take sole responsibility for it, and this event's organizational rock, Ivana, wherever you are, who worked very hard, all the PR people, Joris and Pinar, and the technical team who put this together, Wilco, Richard, Menolt, and Rubens, thanks so much. This evening has been live webcast. Alessandra's been working on that, and it's been broadcasted also on the Fashioning Technology website, so thanks for doing that. The volunteers, thank you. Alex, thanks for letting me disturb your lab for a few months. It was pretty fun. To end the evening, Alex Falk has actually designed we asked him to make a special drink for us, which would be on theme. And so it's clothing without cloth, and we decided to go drink without drink. So essentially, it's a drink that can't be drunk. You have to eat it. Why not? Thanks, everyone. Have a lovely evening.